All right. Welcome, everybody. Thank you for joining us on another webinar by Soft. My name is Nick Zulfikar. I'm the Director of Client Services. With me is my colleague, Ran Hussain, who's our Senior Technology Evangelist. Today, we're going to be talking about NCache architecture. As you know, NCache is an in-memory distributed caching solution. It caches your ASP.NET sessions, objects in memory. And it helps you to significantly improve performance and scalability of your .NET and .NET Core application. Today, Ron is going to take us through a high-level architecture discussion of NCache. He's going to touch upon various caching topologies, as well as use cases and some of the advanced features that NCache brings to the table. So with that, I will turn it over to Ron, and if there are any questions, you can type them in the questions box on the right-hand side of the screen, and I'll be able to ask those from Ron. So with that, Ron, kind of get started, please.
Thank you, Nick. Hi, everybody. My name is Ron, and I will be your presenter for today's webinar. And today we have picked NCache architecture as a topic. NCache is an in-memory distributed caching system specifically for .NET and .NET Core applications. And in today's webinar, we'll talk about some details about the architecture, some technical use cases, business use cases, and some of the important features that you can get started within your .NET and .NET Core applications. So we have a lot to cover. So let me quickly get started with the presentation. I believe everybody can see my screen. I've got a few confirmations. So if everything is good, let's quickly get started with the presentation. First of all, a typical distributed caching system helps you resolve your scalability problem. So your application tier, typically it scales out nicely. You have certain performance under low user load, and you can increase the user load. And at that point, if you feel that your web servers or app servers are being maxed out, you can simply add more web or app server resources into your application tier. For web applications, you can create a web form, you can create a web garden, and similarly, you can also create an app server form as well. An idea behind creating a web form or an app form is to simply distribute load between your web and app servers. ASP.NET and ASP.NET Core or regular .NET and .NET Core applications are pretty scalable because these applications allow you to add multiple servers in a tier and create a web form or a web garden for that matter. But all of these application servers, they would have to go back to some kind of data sources. And typically, it's a relational database. It could be another kind of database as well. It could be a mainframe. It could be a file system. And usually, that is a storage bottleneck. First of all, based on our experience, the typical deployment, if it's a relational database, it's very good for storage. But when it comes to handling extreme transactional processing, right, when you have to have a lot of users logged into your application and those users are, using a lot of, those users are actually exhibiting a lot of request load. So at that point in time, it is a database which can actually choke down. It can, first of all, give you performance issues because it's not able to cope up with the amount of requests. So a request may get queued up and individual requests are impacted. The latency can go up, and similarly your throughput, the amount of requests that you can handle out of the system, that's something that would not go beyond certain limit because your servers are being maxed out. So typically data storage is the main bottleneck, and that's exactly what a distributed caching system like NCache helps you resolve. We have a similar product called NOSDB, along with NCache, which is a distributed caching product. That's a NoSQL database, but that's not usually an answer because NoSQL databases require that your application is redesigned and you stop using the relational data sources and you start using the NoSQL databases and you start adding that data into NoSQL databases. So you need something which you can use in combination to a relational database, such as an NCache distributed caching system. This is a typical deployment of NCache in a typically large production environment where you have Windows or Windows Nano or Linux servers. So with the help of .NET Core, you can install NCache on Linux as well as on Windows Nano. And on Windows, again, you can use .NET Core or .NET installation of NCache, which is fully supported on these platforms. And you can construct a cache tier of 2 or more caching servers. And nice thing about this caching tier is that it's not going to give you any scalability or performance-related bottlenecks. You can have super fast performance out of this system, and on top of it, you can add more and more caching servers. And by adding those caching servers, you simply increase the request handling capacity out of that system. So that capacity is going to increase as you add number of caching servers. And you can have your ASP.NET or ASP.NET Core web apps as clients, .NET or .NET Core apps, or it could be any server applications, .NET and .NET Core. Even Java applications can connect to this distributed caching system. So as far as deployment, since it's an architectural webinar, so I'm going to go have a deep dive into some of the deployment options. So there are two deployment options that you can choose from. One deployment option is that you have dedicated tier for NCache, where you have dedicated servers hosting the cache cluster, and you're forming a cache cluster on separate VMs or separate physical servers. NCache is very flexible in terms of deployment. It only needs .NET Framework 4.7.1 or .NET Core 2.1 at the minimum for installation. And then your client applications, they can have a separate tier. Your web apps or Windows services or any backend workflows that are using NCache, they can be deployed on their own respective tiers. You have a client server model here, so you can install NCache client on the web boxes, or you can use the NuGet packages. Second deployment option is, which is for smaller configurations. Most of our smaller customers are using that, where you have existing application tier also hosting your NCache tier. So you simply install NCache on the same boxes which are currently hosting your application as well. It works, it's supported, but typically we recommend what you're seeing on the diagram, where we have a separate dedicated tier for NCache and separate dedicated tier for your applications. And you get a lot of benefits as well. You have dedicated nature of resources for your applications as well as for NCache. You can bring one web server down and would not impact NCache and vice versa. And on top of it, your maintenance, your upgrades, all the deployment and maintenance related flexibilities are achieved if you have a separate caching tier. And let's not forget the performance and scalability point of view, where your servers are dedicated and NCache is the only product running on those servers. But like I said, both deployment options are available, and as discussed earlier, unlike NoSQL databases, which would replace your existing relational databases for certain data, you can use NCache and your relational databases in combination to one another. You don't have to replace relational databases, although you can push all of your data in NCache, but you can still have your relational data source hosting the master copy of it. So it's the permanent store, which is database. So it's an in-memory storage, so you use it for faster access. So most readily accessed data can be brought into NCache, and then you can have some kind of database synchronization features as well as part of NCache offering. Any questions around deployment architecture of NCache? I believe it's pretty straightforward, so but still please let me know if there are any questions. Some scalability numbers. We discussed two important issues with relational data sources: latency and throughput. So with NCache, you get low latency, and you maintain that low latency under peak loads as well. So you get good performance under 5 users, and if you have 5,000 users or 500,000 users, you still have the same kind of low latency, and at the same time, you're able to handle those requests per second or at a given point in time. So how you do this? You simply add more servers if current servers are being maxed out. So if you have 2 servers and you see that your servers are being maxed out on the hardware side, then network resources are being choked, memory is touching the limit, or they're being maxed out on the CPU. One option is that you scale up and increase the hardware resources, or simpler option would be to create distribute the load by adding another caching server. So you add third server and it would just increase the reads and writes capacity. And if you add a 4th server, from 2 to 4 servers, it would simply double the amount of requests that you need that you can handle with this system. And these benchmark numbers are published on our website as well for each caching topology. I'll revisit these once we go over the caching topologies. For different caching topologies, you can see reads and writes capacity with different number of servers. And it's pretty linear in terms of improvement, so it gives you a linear scalability out of your application architecture. Some common use cases. These are technical use cases of NCache. First of all, you can use it for application data caching. Now, this is a very common use case where you use NCache for database caching. Databases, again, are slow and you end up getting scalability issues. And in some cases, database can also give you reliability issues, data loss issues if you don't have mirroring available. And think of a scenario where a server goes down or you need to perform maintenance, so you need to have downtime on the application as well. So in order to overcome that, you can use NCache data caching APIs. You can connect to NCache. In a application connects to NCache as a client. It connects using the client-side libraries, and based on that, it can cache almost anything inside your application. It could be your domain objects, collections, data sets, images, any sort of application-related data can be cached using our data caching model. And it's pretty intuitive, straightforward API, and we have lots and lots of features available as part of our data caching support. And it's one of the most common use cases of NCache. Second use case is around web applications. There could be an ASP.NET or ASP.NET Core web application, and we have 5 different features which are listed here. And we have a separate webinar on these features as well that you can check on our website. First of all, you can use it for session storage. For ASP.NET or ASP.NET Core, you can have single-site or multi-site sessions. So session variable is going to be automatically stored in NCache. And performance is going to be achieved. Scalability, you don't have to worry about the application load, because NCache is capable of handling linear amount of request loads, linear increase in the request load, and NCache should be able to cope up with that. On top of it, if you bring a cache server down or your web server gets recycled, you don't lose any sessions, because web servers become completely stateless. You don't even need sticky session load balancing with NCache anymore, because nothing gets stored in your worker process. Everything is in NCache. And within NCache, we have data reliability built into the protocol based on replication. If a server goes down, the backup of that server is automatically made available. And session is a very important kind of data that you wouldn't want to lose at any point in time. And this is all achieved without any code changes. We'll spend some more time towards the end once we show you some sample applications around these. Second use case is around legacy ASP.NET web forms. If you have view state for web forms, and that's going back to the browsers, you can store that view state in NCache using our view state provider. And nice thing about NCache view state is that it sends a small token back to the browser. So typical view state is heavy on the bandwidth. It also impacts your performance because it becomes part of your request and response packets. But with NCache, since view state is stored on the server side, a small token is actually sent back to the browser. So that is what you use as a view state, and you actually optimize the bandwidth utilization costs and also improve performance by having a payload of request and response. It would be reduced size, so it would just improve the performance by dealing with lower or lesser payload size in terms of size or in terms of the request and response packets, which are going to be traveling back and forth between browser and your web service. Those are going to be lightweight. So these are 2 features, 2 important benefits that you get out of view state, and this is also a no code change option. Third is ASP.NET output cache or ASP.NET Core response caching. So if you have static content within your application, you can get started with NCache without any code changes. You don't have to execute that content again and again. You can plug in NCache as a provider, and NCache would cache those page responses or page outputs. And when you request the same page or exact same page is required, response is something which is static, it doesn't need to be executed again. You don't have to even go back to the database. You can get a ready-made page output available out of NCache. And this could be entire page, which could be static, or portions within the page. So you can have within controls, you can specify that I want to have a static page output cached in NCache using this provider. And this is again a no code change option. And then we have ASP.NET or ASP.NET Core SignalR backplane. And those of you who are using SignalR within their applications, within web form, you have to have a backplane, right? So database as a backplane or any service bus as a backplane could be expensive in terms of the latency, in terms of throughput. It's not able to cope up, specifically if it's a high transactional application. So you can plug in NCache as a backplane, and it would just improve the scalability and performance side of things for you. And these are almost no code change options for ASP.NET. These are no code change. For ASP.NET Core, these are startup.cs changes. So you just plug in the handler for NCache, and NCache picks up. So these are all use cases almost without any code changes for NCache that you can get started for web applications if you have ASP.NET or ASP.NET Core applications, and NCache can help benefit with these features. Please let me know if there are any questions. These are some of the important topics that I wanted to touch. Towards the end, I'll show you some sample applications and point you towards the right resources so that you can get started with these as well. So please let me know if there are any questions. Third important use case that's getting very popular as well is the PubSub messaging and runtime data sharing. NCache platform, since it has multiple applications connected, you can use that as a messaging platform, and this is a very common use case for microservices. Loosely coupled microservices who are designed to do a simple task, but they must need to communicate with other microservices in some cases. So those some cases where they may need some data or they may need to coordinate, building the communication layer on the microservices is going to be very complicated. So instead, you should just use NCache PubSub APIs, and you can use NCache as a communication channel. You simply publish the messages to NCache, and then that message can be transmitted to all the subscribers who have registered interest in those. And you simply get the message. You don't even need to know about the publisher or subscriber, so it's a loosely coupled, similar to microservices architecture, and it's again getting you a messaging platform with the help of NCache. So this is something which is very popular, very powerful within NCache. You can have linear amount of, you can have a huge amount of, messages load handled with the help of NCache, and this system would simply scale out as your load grows. And on top of it, there are lots and lots of features in terms of, in terms of message delivery and in terms of publisher and subscribers that they can utilize. And then there's another extension of this feature where we have continuous query events. You can map a criteria on the cache. You can map certain records based on an SQL-like query. For example, you can map all the products under, let's say between $10 to $100. So that's the criteria that you want to map. You can simply use that as a query, and then NCache can monitor those products for you. So you don't have to monitor all messages, all items, if they're changing, getting updated, removed, or getting added. You can simply monitor items of interest. So and NCache would send event notifications if an item joins the criteria, gets removed from the criteria, or gets updated and stays within the criteria. So that's another kind of use case. I hope this gets you a basic idea of where you can use NCache, and this list goes on. There are many other use cases as well based on the industry verticals. You can use it in banking industry. You can use it in airlines. Lots of our customers are associated with airlines, with financial, with e-commerce. So that list actually goes on. You can always find a use case for NCache where your typical application is having scalability or performance issues, for that matter. All right, next segment is around NCache architecture, but before I move on to that, please let me know if there are any other questions. Assuming everything is good, so I'm going to move on. Is there a question?
Yes, I actually have a question. There's an architectural level question. Can there be a firewall between the caching tier and the application tier?
Yes, of course. NCache is a TCP/IP based communication protocol. So if you need to have, typically there's a firewall. Your web servers are exposed, and then typically there's a firewall between your web servers and your internal network. So if you need to have a firewall between your clients, which are your web and app servers, and then NCache servers, you can have that, but you need to ensure that NCache ports are open for communication. And then if it's a sensitive data transmission that you want to restrict, you can set up some security and encryption related features so that you make sure that data transmission between NCache and your application is secured. So to answer this, yes, but you need to enable NCache ports for communication. All right, I hope that answers this question. Next segment is actually focused on NCache clustering. Self-healing dynamic cache cluster. This is core of NCache. This is not Windows clustering. It's our own implemented TCP/IP based cache clustering protocol. It's a 100% proprietary peer-to-peer architecture protocol. So based on peer-to-peer architecture, there's no single point of failure. There's no master-slave or majority rule concept as you would have seen with other products. NCache is purely peer-to-peer architecture. Each server joins the cache cluster in a 100% independent capacity, and it's fully capable with all the configurations actually available on that very server. So it's very dynamic in terms of adding or removing the server nodes from this cache cluster. So you can add or remove servers at runtime, and you don't have to stop the cache or any of the clients which are connected to it. So it's purely dynamic in terms of its functionality. And on top of it, clients are very intelligent as well. Your client application is using NCache libraries to connect to NCache. NCache protocol ensures that those clients are always aware of what are the current number of caching servers which are currently part of NCache. So if you add a new server, they get notified at runtime. And if you remove a server, they detect that, and servers notify that this server is no more part of the cache cluster. And at that point, clients can fail over their connections automatically and start using the survivor nodes. So let's take an example of 3 NCache servers. If you have 3 NCache servers and one of those servers actually go down, or you bring that server down for maintenance, what would really happen is surviving 2 nodes would detect that this server is no more available, and they would try to reconnect automatically. There are a number of retries that you can have, and after those retries, if those servers are still not that server is still not reconnected, they would conclude and update the map of NCache, and after that they would notify the clients, and this is done instantaneously. The server detection is something which is built into it. It would notify the clients, and clients would simply fail over the connections and start using the survivor nodes. So automatic connection failover, server health detection, client to server communication, the membership information map, this is all part of NCache protocol, which is seamless to your end users. Your applications do not see any glitches, and you simply add a new server, and your application would automatically start using the new server. And similarly, if existing server gets out of the cache, there's a power failure, or you bring it down for maintenance without your application getting any impact, they would automatically start using the surviving nodes. So if you had 3 servers, 1 server goes down, 2 servers are still up and running, clients would start using them. If another server goes out and there's 1 surviving node in the cache cluster, client application would still be up and running, and that's the minimum that you need. You need at least 1 surviving node in order to have 100% uptime, a highly available cache scenario for your application. And this is again all built into the protocol. Everything is seamless to your end users. I hope that clarifies some of the clustering details. We're going to actually extend this discussion to caching topologies. How exactly you can formulate a cache cluster, and what are the architectural details around that? There are 4 different options that you can choose from. We have mirrored cache. It's an active-passive setup, and then we have replicated, which is an active-active. So these 2 topologies are for smaller configurations, typically for 2 to 3 NCache servers, and for smaller to medium customer deployments. And then we have partition and partition replica, which are suitable for smaller as well as for bigger configurations. So it all depends based on the use cases. And before we actually move on to this section, I will drive this discussion around caching topologies in regards to your data types. And by data types, I actually mean the nature of the data, whether it's a reference data or transactional data. Now, reference data is the data which you read a lot of times, then you update. So if it's more reads than writes, that data is the reference data. It's not 100% static data. You do update this data, but frequency of change is not that great. And typically, this data belongs in the database. These are your product catalogs, for that matter. And then we have a transactional data use case where we have data being read, and at the same time, data is being updated as well. ASP.NET Sessions or ASP.NET Core Session is a prime example of that, where each user has its own session. It's a temporary data, transient data, and it's being updated and being read a lot of time while that data is active. And after your user goes away, chances are that this data may also go away. But based on the usage pattern, read intensive or read and write intensive, it's going to be reference and transactional data respectively. And I'm going to recommend these topologies based on reference and transactional data and based on scalability requirements that your applications can have. So first topology is mirrored cache. And guys, please let me know if there are any questions. I would welcome all the questions around this. This is going to be an extensive discussion about the caching topology, so please let me know if you would have any questions. So first topology is mirrored cache. It's a 2-node active-passive setup. That's the standard setup configuration that you can have. You cannot go beyond 2 servers, and out of those 2 servers, 1 server automatically becomes active, 2nd server automatically becomes passive for that. Clients open connection once you connect to the cache. Clients open connections to the active server, And then they are aware of the passive server as well based on the protocol. Server notifies the client that there's a passive server that I'm using as a replica. And this is all part of the protocol. Now, server 1 replicates data to server 2, and mode of replication is asynchronous. By asynchronous replication, what we're really doing is we're delegating the task of replication to NCache. Your application becomes super fast as a result of that, because it only updates data in NCache server 1, which is active at that point, and behind the scenes NCache would update the operation on the backup as well. But at any point in time, these two servers are in sync. There is an active copy and there's a backup copy, and we have 6 items here. You would, by design, you would have 6 items on the passive server as well. Now, read and write intensive data. This is a very good topology for reference data as well as for transactional data, because you read from the server on which you're connected, and that's the active server, so reads are super fast. And writes are also super fast because you update the active and you return, so writes performance is going to be very good with this topology as well. On top of it, this is very reliable as well, because if a server goes down, for example, you lose active server, clients would detect that and they would automatically fail over the connections to server 2, and at that point server 2 automatically becomes activated as well. This is again seamless to your end users. So if a server goes down, replica of that, the passive server, which is passive at this point, becomes, it gets promoted to active, and then it gets all the client's connections failed over to itself. And this is instantaneous, without any data loss, without any application downtime. Your applications would start functioning, and you already have the data on the other server, so your application would fail over and start using this. So it's very good for reads, very good for writes. It's very reliable. Only downside of this topology is that you only have one server, so there's no scalability within this topology. You cannot scale beyond one server, and that's the capacity that you get when you use this. Second topology, again for smaller configuration, is slightly different from mirrored cache, is our replicated cache. Now in replicated, we have each server active, so that's one difference between mirrored and replicated. And then we have a copy of cache on each server, and that's the design, because we have a copy on server 1 and we have the exact same copy on server 2 as well. And this is done with the help of synchronous updates. So whatever updates that you perform on server 1 are going to be performed on server 2 by rule. That's the architecture of this topology. And similarly, if you apply any updates on server 2, those are going to be applied on server 1. And this is a two-way synchronization, which is happening all the time. And this is a sync update, which means clients are the ones who are updating server 1 and server 2 at the same time. So one operation on server 1 means an operation on server 2 as well. So writes performance is going to be compromised if you have a lot of servers, but for 2 servers, it's something which is affordable. And as for reading the cache from, reading the cache is concerned, clients are automatically distributed. There's a feature within this topology. It's called connection, balancing, connection displacement between the servers. So that's something which is again built into the protocol. So if you have 6 clients, and if you have 2 NCache servers, as shown in the diagram, 3 of them would connect to server 1 and 3 of them would connect to server 2. And this is done automatically. If you had, let's say, 3 servers and 6 clients, 2 would have been connected to server 1. In that case, 2 would have been connected to each server by distributing the client connections. So client connection balancing is built into the protocol. So based on number of clients and based on number of servers, NCache automatically distributes client connections, and clients are connected to only one server at any given point in time. So these clients are connected to server 1, they have entire copy of cache available. And similarly, these clients are connected to server 2, again, they have entire copy of cache available. Reads performance is super fast in this topology because you're reading from the node and you return. Write performance is going to be synchronous, it's coupled with a synchronous update. So each write, if you have 2 servers, is going to be 2 times the write cost. So it's very good for reads. That's the main use case for it. But it's for smaller configuration, it's okay for writes performance as well, based on our experience. But if you increase the number of servers, writes performance is going to degrade. So we recommend it for smaller configurations and mostly for read intensive data. So that's the use case for this. Now, if you lose any server, it's very reliable as well, because these clients simply need to fail over and start using the other server. And similarly, if you lose server 2, these clients fail over automatically and start using the other server. So at any point in time, clients can fail over if a server goes down. So for reference data, scenario, and for reliable data transactions, this is a very good topology to have. Again, for smaller configuration, very scalable for reads, not that scalable for writes. and I'll show you some benchmark numbers for these two topologies. You can see mirror with 26,000 reads and 20,000 writes per second performance, and then comes the replicated, which is going to show you with 2 nodes and 3 nodes, reads performance is increasing, but writes performance is going down because there's a sync update model implemented in this. Please let me know if there are any questions. Otherwise, I'm going to move ahead and start discussing the partition and partition replica cache topologies. So please let me know if there are any questions at this point. All right, assuming everything is good. Next topology is partition cache. This is a performance-centric cache topology, and I think I have some samples available as well. All right, for partition cache architecture, this is purely for scalability and for performance-centric scenarios. And let me explain the architecture. We actually have data distributed in the partitions, and it's an automatic division of your cache into partitions. If you have 2 servers, you would have 2 partitions. If you have 3, 4, 5 servers, based on number of servers, you would have number of partitions accordingly. And this is done automatically. Once you create the cache, NCache protocol takes over, and it automatically starts distributing data to number of servers and formulates the partition. Now, partition is done with the help of, there are buckets of data which are distributed, and there's a distribution map. So at any point in time, some items would be on server 1, some items would be on server 2, and clients are aware of those distribution maps because clients are the ones who are distributing data. Once you're adding data based on number of servers, a key goes to server 1 or server 2, and this is done by the client with the help of a distribution map which client receives once it connects to the cache server. So based on distribution map, it's a very intelligent algorithm, a hash algorithm which hashes the keys on different servers. Clients are always aware where data exists. So they're already aware that item number 1 and 2 are on server 1, and item number 3 and 4 are on server 2. And if you add a third server, distribution map changes because it needs to create another partition, and clients are propagated with that information. So at any point in time, clients are aware where data exists, and by doing that, with the help of this ability of knowing where data exists, calculating where data exists, clients' performance for reads and writes separation is going to be super fast. Reads are very fast, writes are very fast in this topology because clients are connected to all the servers and they exactly know where data exists. So reads and writes performance is going to be super fast in this topology. Now, another benefit of this topology is that you're pooling the memory resources together. So if you have 4 items, those are distributed on 2 servers, and you have allocated 1 gig of cache size. With 2 servers, you get 2 gigs. If you add another server, you get 3 gigs. So you're pooling the memory resources together of all the servers if you have more number of servers. And by having more number of servers, you're also increasing the request handling capacity because you're pooling their computational power together as well. So it's a team of servers. Each partition is only responsible for its own data request. So more servers mean more request handling capacity out of the system. So to sum it up, this topology is very good for reads, for reference data scenario. This is very good for writes, super fast for writes as well. If you have 2 servers, it's going to work very well. And if you add more and more caching servers, and it allows you to add as many servers as you need to, it's going to linearly increase the request handling capacity of NCache as well. Only downside of this topology is it does not have any backup. If you lose server 1, you lose that partition. And for those applications with this understanding, and by the way, this is not going to give you any application downtime. If a server is lost, it's still highly available. Unlike other products where replication is a must for high availability, NCache allows you to simply fail over your connections and start using the survivor nodes as you would do with other topologies. But with this, you lose the data. And that's the understanding within this architecture. We've given this with this disclaimer that if you can reconstruct your data and you need more performance for reads and writes and scalability, only then pick this topology. Don't use it for ASP.NET Session because session is an important kind of data, and bringing a server down can have a data loss. So if you bring a server down, you would lose that partition and you would have to go back to the database and you would not get that data from NCache. You have to reconstruct the cache by adding that data. But again, let me just be very clear, it does not give you any application downtime. You just don't have the data in the cache. You may get a null for a request if that data was previously part of NCache, and by bringing a server down, you lost that data. So that's partition cache, and finally we have partition replica cache. That's our fourth caching topology, and this is very similar to partition cache with an enhancement of replica, with the enhancement of backups. So all the benefits of partition cache are going to be bundled into partition replica cache, and this is exactly why this is our most popular topology. It also gets you one problem that partition cache had, that it didn't have any backup. This also comes with backup, so it's fully equipped. Let me give you a quick overview of architecture. So in partition, we only have one partition which was active. In partition replica, we have two partitions per server. There's an active data partition where clients are connected, and then there is a passive replica of another server, which is for backup purposes. So one's active, item number 1 and 2, it has backup on server 2. Server 2 is active, it has backup on 1. So each server has a backup on another server, and this is automatically created. You just pick up the caching topology, NCache would formulate the actives, it would automatically decide the backups, and we just create two partitions per server. And this passive partition is not updated by any client, it is updated by another server's active. And by the way, mode of replication can be sync and async. This is another difference between these topologies in partition replica, that mirrored only had async, replicated only had sync, whereas this one has sync as well as async replication options. So both options are supported within this topology. So with sync, clients are updating the active as well as the backup, so it's a 2 times the operation cost, but for sensitive data or for consistency, you can choose to have this. And then async, client updates the active, returns, so it's going to be super fast. NCache would update the backup behind the scenes, and it's within sub-milliseconds based on our experience. Now, how exactly? It's very good for reads, as you had partition replica, very good for writes. We have the same distribution map model. More servers mean more scalability, more request handling capacity, pooling the memory resources together, so all the good stuff. And on top of it, it has replica. So if a server 1, any server goes down, let's take an example of server 1, its replica, which was previously passive replica, becomes activated automatically. So there would be a detection, and once it's concluded that server 1 is no more part of the cache cluster, server 1's backup, which is going to be on one of the surviving nodes, is going to be promoted to an active, and it is done instantaneously. And clients would right away start using the backup, previously backup and newly active partition from server 2. So you get all the data from server 2, so there would be no data loss, no application downtime, and all the benefits that we previously have covered. Similarly, you can see the difference between these. The only difference is replica. Similarly, from 2 to 3 servers, this is going to be slightly different, where we have server 1's active, backup on 2, server 2's active, backup on 3, server 3's active, backup on 1. So in a round robin fashion, each server has at least one. Actually, it only has one backup on another server. So let's take an example of 3 servers. If you lose server 1, server 1's backup is going to be promoted. So it's activated right away, clients start using it, and then this backup merges into the active partitions of server 2 and server 3. And server 3 formulates a new backup on server 2, which was lost from server 1 automatically, and server 2 completes its backup. So cluster would heal itself and formulates a 2-node healthy cache cluster automatically. And this is again one of the features where NCache specializes. It is 100% peer-to-peer architectured, and by losing a server, you don't have to formulate a majority rule, or you don't have to have minimum number of servers to host a cache cluster. So if you lost 2 servers, you had 3 servers, you lost 1 server, cluster would heal itself and formulate a 2-node healthy cache cluster. If you lost another server, cluster would again heal itself and formulate 1-node cache cluster. It's not really a cluster, but it's 1 node with full data populated on it. So without any downtime, without application data loss, you can continue to work, and you get all the benefits of high performance for reads, high performance for writes, and super scalability in terms of adding more and more caching servers. So this is why this is our most popular topology. It works very well for smaller configurations, 2 to 3 servers, and it can scale out by adding as many servers as you need, and you can use it in enterprise configurations as well. Please let me know if there are any questions at this point. I see some questions. Nick, please let me know if there are any questions.
Yeah, there is a question regarding the limit on total number of servers. Does NCache have any sort of an upper limit on how many servers you can have?
None. With partition replica, you can scale out to linear level. That's how the protocol is designed. You can have 3 servers and you can add 4th, 5th, 6th server at runtime, and it does not limit you. And by adding more servers, if I revisit this diagram right here, you can see with 6 servers, it scales out in a linear fashion. This is partition replica. So you can add as many servers as you need to. There's no limit.
Okay, thanks.
Very good. Next, I'm going to talk about client cache, and then I'll take you to our demo environment and show you the actual product in action. Another topology for this clustered cache. NCache already is resolving your access to the database, which is expensive, so it's saving those trips and giving data from a faster source. You can further improve NCache's performance using a client cache feature. Now, in a setup where we have a client-server deployment, your applications are on separate tier and NCache is on a separate tier, you can turn on client cache feature. It's a local cache. It's just a configuration that you need to set up as part of the cache configurations, and it gets created on your application boxes, on your web servers or app servers. And then this works as an L1, L2 cache between your local client cache and your server cache. NCache server cache, having 2 to 3 NCache servers, any topology is hosting your master data, let's say 100,000 objects. But this client cache would fetch in data automatically based on your usage pattern. For example, you fetch 100 items or 1,000 items, those are going to be brought into the client cache automatically. And next time your application, the client cache protocol is intelligent. Once you start using this feature, it would first check whether that data exists locally in the client cache or not. If it does, it doesn't have to go to the server cache across the network, and it would find that data closer to the application, similar to L1, L2 cache in the hardware. And similarly, once these client caches are populated, you save your trips across the network, and these client caches can also be in process to your application. If you have your applications also hosting NCache client cache, you further save serialization as well as inter-process communication overhead. So for read-intensive data, and I'll explain why it is read-intensive data. It is a must-have feature where you can turn on a client cache, and if data is not changing that frequently, you get to have data closer to your application in a faster in-proc or out-proc client cache, and that would just improve your performance. Now, one problem with client cache could be that data exists in 2 different places and in multiple client caches. So what if you change something here and this has a copy which is stale? NCache fixes that problem as well. NCache client cache is a 2-way synchronized. It's 100% synchronized client cache. So if you make any change in the client cache in one of the worker processes or one of the web boxes or app boxes, that change is going to be propagated in the server cache as a rule, because server cache is the master copy for it. And then server would in turn transmit that change to the other client cache. They would notify that this item has been updated. So we have different mechanisms. There are 2 different modes of synchronization, but synchronization is fully managed by NCache. You just configure it. It's a no code change option. Inside your application, you just keep using as you would use the server cache. And if you have this client cache turned on, you would get performance benefits. It would give you some dramatic performance improvements from let's say from 40 seconds. We did this test study with one of our customers where we brought test case performance from 40 seconds to 12 seconds, and then from 12 seconds to a couple hundred milliseconds with using client cache, without client cache out proc, and within proc. So that was the kind of improvement we were able to attain. Then we have last caching topology here, and then I'll move on to our hands-on portion. WAN replication. Is there a question?
Oh, quick question here, Ron. Where would you recommend for us to use in-proc versus out-proc within client cache? What sort of use cases would you recommend for each one?
Okay, so first of all, use case for NCache is reference data scenario, right? So that's the general guideline. And then between in-proc and out-proc, typically if you have one worker process, it makes more sense to keep it in-proc because you would have one client cache within the application and you improve further performance. But if you have a web garden where you have, let's say, 4, 5, or 6 worker processes, keeping in-proc client caches would just be redundant because each worker process has a lot of one web server having multiple worker processes would have a lot of caches based on those worker processes. So in that case, we recommend that you keep out-proc. So if you have one worker process, keep in proc. If you have multiple worker processes, let's say 3, 4, 5, keep it out proc. So that's the understanding for it. All right, WAN replication, we also have another topology, which is for multi data center deployments. Bridge cache cluster is part of the same product. You can plug in 2 caches with the help of bridge. You can have a cache connected to the bridge, and then you can have another cache which could be from another data center across the WAN. And bridge is a queue. It's an active passive queue, so it takes data here, and then that's also backed up. So you can have separate servers hosting the active queue and the backup for bridge as well. So it's a bridge between these 2 environments, and your cache data can be transferred from one data center to another. It could be active passive, and use case for that could be the DR site, where if this site goes down, you can make the backup activated. And second use case could be east to west migration. For example, there was some data which was being published from the eastern side of your data centers, and as day shifts towards the western zone, you already have that data promoted to the western site as well, right? So you can have east to west migration out of this as well. This is async replication from cache 1 to bridge, and from bridge to the target cache. So cost of this replication is not incurred on the end clients. So this is something very optimized, and behind the scenes it actually replicates data from one data center to another. You can also have active deployments as well, where both data centers are transferring data to one another. Typical use case for this could be multi-site deployments, geographically distributed sites, but they need data where one user can bounce from one data center to other, or data from one data center is needed on the other side, and vice versa. So you can have active where this site is transferring data to site 2, and site 2 cache is transferring data to site 1. And we have intelligent conflict resolution already implemented in this, which is based on the time, but you can have your own conflict resolution. Intelligent data types you can have your own conflict resolution built into the bridge, and you can plug in conflict resolution of your own as well. So if there is a multi-data center approach, and we have lots and lots of active deployments who are using active as well as active passive. So please let us know if there are any questions, and this is one good feature that you can get started with. Essentially, this completes our architectural portion of NCache. Please let me know if there are any other questions. I'm going to move on and show you the actual product in action. So all the discussion that we've done, I'm going to actually demonstrate this with the help of our demo environment. Since NCache can be deployed on Windows as well as on Linux environment, so I have a demo of both. I'm going to use 2 NCache servers and 1 NCache client on Windows, and I'm going to have the same setup on Linux environment as well using .NET Core. So on Windows I'll use GUI tools, and on Linux I'll be using the PowerShell commandlets for that matter. I've already downloaded and installed NCache, so that's step number 1 in a typical getting started section of NCache. So you need to download .NET or .NET Core installation for Windows or for other environments for Linux. I've already downloaded and installed. Next step is that I'm going to actually get started and create a named cache. So so I'm just going to name it demo cache, and I'm going to append a window. It's not case sensitive, so you can choose that as is. All caches need to be named. I'm going to go ahead and choose next. Here you pick any caching topology. We covered 4 caching topologies. I'm going to go ahead with partition replica cache because that's the most recommended one. And I'm going to choose asynchronous as a replication option. Async is faster, sync is more reliable. And I'm going to specify demo 1 and demo 2 as 2 servers which are going to host my cache. And by the way, all of this can be scripted using command line as well as through PowerShell. And then in Linux environment, I'll show you some of the PowerShell commandlets as well. So that's it. I can add more servers at a later stage, but at this point I'm good to go. TCP/IP protocol is what NCache uses for server-to-server and client-to-server communication. So this is a port which is going to be used for this cache cluster. You can create multiple clusters, so each cluster has its own port. You need to make sure that if there's a firewall, you enable these ports for communication. Size is again on each server. If you have 2 servers, you get 2 gigs of cache size. For partition replica, since we have active and backup on the same box, 1 gig means actually 2 gigs on each server, because 1 gig is for active and 1 gig for the backup. So with that considerations, you can choose next, and you can provide any big cache size as needed based on the data that you plan on adding. And then if your cache becomes full, there are two options. One option is that you reject new updates. Other option is that you keep the cache running, but removing some of the items from the cache automatically using evictions. So for sessions, I would recommend that you turn off evictions, don't lose any data, and keep the cache big enough so that it never becomes full. But for items such as object caching, some data which is there for and it's not that heavily used, and you can afford to lose it if your cache becomes full. So you can automatically do that with the help of evictions. And these are the protocols, these are the algorithms: least recently used, least frequently used, and based on the priority of items, you can remove some items, and this would make room for the new items. I'll keep everything default, and I'll pick auto start so that each time my server gets rebooted, cache automatically gets started. I don't have to manually do that, and choose finish, and that's it. That has created my cache cluster, and my cache has been created as part of step 2. Step number 3 is to add a client node. I've already done installation on my box. This is optional if you're using NuGet packages. In that case, you can just connect to NCache directly by specifying these IPs. And configurations are updated on server 1 as well as on server 2, and on my box I have the client-side configurations to connect to this cache. Step number 4 is to start and test this cache cluster, and I would be able to show you some performance numbers as well. So it would get started, and then I should be able to test this. All right, I'm good to go with this. I right click and choose statistics. This would open perf month counters. This is a window that I can use for to review some activity. I'll open another tool which comes installed with NCache. It's called Monitor Cluster, NCache Monitor. And this gives me some pre-configured dashboards that I can quickly use. Next thing is to actually run a test application which comes installed with NCache. I'm going to use test stress, and I'm going to simulate some dummy load on my cache cluster. You would see a client getting connected to both servers. That's how the architecture is. And we have active and backup on each server. In this case, we have active partition count, and then the backup is of this server is on the other server. And similarly, server 2 is active, its backup is being maintained automatically. Actives are taking requests right here. Backups are just there for the backup purposes. If a server goes down, backups are going to be promoted as discussed in the architecture of this topology. And you can see requests per second graph being populated, about 1,000 requests per second by each server for 1 kilobyte average object size. I'm going to increase this load by running another instance of this. And you would see a surge in the requests per second because I've doubled the load. So it is actually managing that. Now 2,000 requests per second by server 1 and 2,000 requests per second by server 2 as well. So you can keep on adding more and more load, and it would just accommodate that by distributing it. And at any point in time, you can add another server, and it would just take over from that point. This is our Windows demo. I'm now going to show you the Linux side of things. That's something which is here. I have 2 boxes, so I have cache configured on. That's something that I've already configured. So if I show you the cache, the cache name is demo cache right here. So it's configured on 117 as well as on 118. So I've run get caches, which allows me to see what caches are there. So this cache is configured. Next thing is I'm going to start this cache. So for that, I'm going to use a command from here. Let me just copy it real quick so that it's convenient. All right, I'm going to start the demo cache, and since it's created on 117, so I'll start on 117 first. It would take time and start that. And what I'll do next is I'll show you the statistics of this demo cache, partition replica type, size of the cluster, and we have 117 started here. I'm now going to start it on 118, and 118 would join and become part of this cache cluster. And you'll be able to see the output. If I show you the output from 117, now we have 2 servers. And if I quickly show you the output from 118, you should be able to see the same output from there as well. Next thing is that I test this using test stress and then provide the name of the cache, demo cache. For .NET Core Linux deployment, all the PowerShell commands are available for creating a cache, adding a node, stopping, starting, and testing it. So all the management tools are available, but as far as monitoring is concerned, you can rely on Windows because .NET Core does not have perf support on Linux servers as yet. But we have given that feature out of the box. We have provided that support through Windows boxes. So if I bring back the Windows environment, I can manage and monitor Linux servers from Windows box as well. So if I just add existing, provide the IP address of one of the caching servers, I should be able to load this cache in the Windows environment, and I should be able to see all these statistics. And you can see the request coming in to active and then the backup being populated. And if I just run another instance of this, let me just run another instance from here. Actually, you're right. I would just have to monitor cluster this, so I can run another instance of NCache monitor tool, and I can monitor Windows Linux caches, .NET Core Linux NCache caches on .NET Core on Linux through Windows box as well. So all the monitoring and all the management support can be done through Windows as well as through Linux boxes. So this completes our demo. Final segment is around using the application in an NCache in an application. All you have to do is add these namespaces, add NCache NuGet packages, and this is our API.
Quick question, Ron. Could you talk a little bit about how to validate and make sure that the caches that you have created are running properly? If there are any issues, if they're partially connected or things like that, how do we monitor health of cache?
All right. First of all, it gives you a dashboard within NCache which says fully connected. Second is that you use the view cluster connectivity box from here, and this output is same as of list caches or get caches within NCache, the one that I've shown you in the Linux environment. And then there are lots and lots of alerts. You can have alerts set up, right? And based on that, you can have email alerts, specify your recipients, and then you can get notified if a cache gets started, gets stopped, size becomes full, or it actually gets disconnected for any reason. And we also have event log entries which are published by default. So that's something that we do as by default, so you can get event IDs and set up some monitoring, a custom monitoring if you need to. But NCache gives you a lot of monitoring options within its features, so I think those should be good enough to get started. All right, I'll take 1 to 2 more minutes to conclude this. So you initialize this cache, and here is an excellent sample for this. These samples are available inside NCache samples. .NET and .NET Core samples are available. I'm using a basic operations .NET Core sample. And what you really need to do is simply include these namespaces, add NuGet package or add references from GAG directly if you have installation. Either way, it works. And then you connect to the cache by using initialize cache from here. This is the command, and then after that you can add items to the cache by calling cache.add, get items from the cache by calling cache.get, and similarly you update the items by calling cache.insert. On the same lines, we have ASP.NET and ASP.NET Core session storage. Again, you need the NuGet package. I have session state for this particular project. This is a .NET Core application, and once you've done that, I really hope it gives me, I shouldn't have, let me just go to, all right, it's not letting me control this sample anymore. So all you need to do is plug in NCache. Here is a command for it, app.use NCache session. But before that, I have plugged in NCache handler inside startup.cs. So that's the change I wanted to showcase, but I think it's not letting me do that. So NCache, I think I've got the control back. Very good. All right. So all you have to do is within services, within startup.cs, you have to have services.set NCache session, and you provide a config section, which is appsetting.json. And based on that, you can load cache name, some of the session related settings. And once those settings are loaded, for example, the cache name here, you can simply called services.add NCache session, and that's it. And then once you use session variables, it would automatically go to NCache as part of that. So that's how you use object caching and session caching, and there are huge amount of features within this. You can have SQLite searches, you can have link queries, you can have groups, tags, server-side code, read-through, write-through, cache loader, map reduce, entry processor, and then you can also have pub/sub messaging and all the technical use cases that we covered at startup. I hope this gives you an insight into NCache. At this point, I'll conclude our technical presentation. Please let me know if there are any questions in terms of architecture or in terms of the usage of this. We have detailed help documents available as well that you can use as reference.
Thanks, Ron. It was very informative. Guys, if there are any questions, kindly type them in. I have a couple of quick questions here, Ron, for you. Can you explain how to handle configuration where cache server has 2 NICs and remote client has multiple IPs but single NIC?
All right. For NCache, you just typically by default it only uses one network interface card, right? And that's something that you get automatically picked inside the configuration files. There is a manager option of that as well, but I want to show you this real quick. So on the server, it allows you to specify one NIC is good enough to get started. So if you go to bin services, there is this ncache service.exe.config, right? So and in this we have an information where we can have server to server communication mapped to one NIC and then client to server communication map on another NIC. But typically, as I've mentioned, it is going to be one NIC by default. So you can directly come here and specify 2 different NICs if you need to have one NIC for client to server connections and one NIC for server to server connections. That is a feature which we term as dual NICs feature. And you restart NCache service after saving this file. A convenient way of doing this is through the manager as well. If you right click and then let me just quickly see, select network interface card. And in this, if you notice, we have 107 choosing, using both cluster and client. Alternatively, I can have one NIC for client server and I can have another for cluster, right? So in that case, you can use 2 NICs for NCache server. But that feature should only be turned on if you're seeing some capacity related issues. If you're seeing one NIC being maxed out on the capacity, it's using 50% utilization, and other NIC is sitting idle. If your network interface cards are showing 10, 15, 20% utilization, you're good to go with one NIC. I don't see any other advantage of having 2 different NICs. Only benefit of this is it's going to improve performance if you have capacity related issues, if one NIC is being maxed out. But that's how you would change it through GUI as well as through configs. Any other questions?
Great. Thank you. Another question, does NCache support third-party database integrations such as Entity Framework?
Well, the Entity Framework is an ORM. Yes, NCache has a full support for Entity Framework. You can have EF or EF Core. NCache can be plugged in as a second-level cache provider. It could be a no-code change option, and for EF Core, we also have extended some of the methods in EF Core where you can use those extension methods for NCache. And I believe we have a separate webinar on EF Core around this. But just to summarize it, Entity Framework Core NCache can be plugged in as a second-level cache provider, and it's fully supported.
Great. Thank you for that. I don't see any other questions. I know we're kind of running over the time as well, so I would like to thank everybody for joining us today. Just remember, you can download the trial version from our website at alachisoft.com. If there are any support-related questions, any technical inquiries, you can send an email to support@alachisoft.com. For any sales-related questions, you can always reach us at sales@alachisoft.com. And if there are no more questions, I'd like to thank you and thank Ron for attending and joining the presentation today. And we're looking forward to seeing you in the future. Thank you. Thanks,
Ron. Thank you, guys. Thanks, Nick. Thank you, everybody.